Hey y'all, we're going to take a look at adding rational expressions with equal denominators. This is a big it's a long way of saying we're going to add fractions. That's it, with equal denominators. You know how to add fractions, right? What are the general rules? If the denominators are the same, you just plop together the numerators and you're done. If they don't have the same denominator, then you make them the same denominator, and then you add them, and then you put it all over one thing, right? So you can have 2 twelfths plus 3 twelfths plus 5 twelfths, and then that's all 12ths. But if you have a 1/3 plus 4/5 plus 7/8, you got to figure out your denominator, change all your numerators to match everything, and then all together in one thing. Don't make that noise when you do that. But anyway, so something like this is a piece of cake, right? 14 elevenths minus 17 elevenths plus 19 elevenths. Well, it's just going to be 14 minus 17 is -3. -3 plus 19 is 16. 16 elevenths, right? No big deal, all right? This one, well, if this works with real numbers, then this works too, right? Look at that. You don't have to actually write this down. Look at the denominators. It's the same, right? So all we got to do is just, chuck this all together. So we got a 4 here, we got a minus 6ax, and we got 19. So we can just go, okay, 4 plus 19, 23. Minus 6ax, minus 6ax. And then the whole thing, you plop it over 2x squared plus y. We don't care about this. We don't have to do anything with that. That's the same thing as going all those 11s. It's the same exact thing. If it works for numbers, it will work for this. It's the same exact principle. So, okay, and that's it for that one. Okay, let's try another one. Again, you don't have to write this down. It seems like almost like a waste of time. Look at those denominators. Look at them. Same thing, right? We got 3 fractions of the same denominator. Well, you can just chuck it all over one denominator. A squared plus 7y. We don't care how complicated it looks. It's the same. Just write it once. 5 minus 3 is 2. 2 plus z. That's all you can do. Just put 2 plus z. Don't put 2z. You're just adding. That's it. That's all we need to do. Look at that one. Now that's slightly different. There's a slight difference in this one. And if you notice, both of those denominators have variables and constants. Okay? One thing you're going to have to watch out for on these. First off, we know that this is going to be 5a squared x as a denominator because they both have the same thing, right? The one thing to watch, though, is you are subtracting this entire shebang right there. You're subtracting the whole thing. In other words, this minus is going to apply to the 3x, and the minus is also going to apply to the -2. It's almost like saying the opposite of those two things. So make sure when you do that, you end up doing it correctly. So at the top here, in the numerator, we have 5x plus 7. Then we have a -3x. Then we have the opposite of -2, which is +2. Okay? Now, what can you do with that numerator? You tell me. Look at that numerator. You see something we can do? We can add like terms, right? We got a 5x. We got a -3x. That gives us a 2x. I got a 7, and I got a 2. That gives us a 9. We can just go over the same denominator. We don't care. It's the same thing. We're done. That's all you need to do. Okay? Well, that was 3 fast ones. Okay. Here's a hard one. What do we do? Oh, no. On this one. Obviously, what do we do here? We make this into a common denominator, right? So this is going to be 5 over 6 minus 3 over 6, right? It's going to be 2 over 6, and of course we can knock that down to 1/3, right? You know how to do that. Well, guess what? If it works for numbers, you know the rest of that sentence, okay? How about that one? You can always, now this is where your times tables and your division tables are critical, because you can make 48 the denominator if you wanted to, but it'd be easier to do 24 because 8 and 6 both go into 24. But if you did 48, you would just need to reduce it one more time to figure out the answer, okay? Well, let's do exactly the same thing. Go ahead and copy this one down. Pause and copy. Okay, this you are going to treat exactly the same as you would any other fraction you do in the world. It doesn't matter that there's a b down there. You're just trying to find the common denominator, right? On this question here, your question was, what do 8 and 6 both go into, right? Okay, the question on this is, what do 4 and b both go into? That's all you're doing. Now what do 4 and b both go into? 4b, right? You just have to multiply those together, if nothing else. So you can rewrite these two fractions with a common denominator, just like you would do on any other fraction you ever added in your life. Except at the very beginning when you started crying and stuff and it was too hard. Okay, anyway. All right. Well, let's do something very quickly. Let me change this a little bit. I didn't mean to do that. Anyway. Okay, let's do this part right here. I'm just going to go ahead and write 3/4 like it is, and I'm going to write 2b like it is. Okay. Now, we said correctly that the common denominator was 4b because 4 and b both go into 4b, right? Okay, so we need to have a 4b and we need to have a 4b, right? Okay, which means on this left fraction, we multiplied by b, correct? And if we did the denominator by b, we also do the numerator by b. On this one, we went 4 times b. So over here, we need to go 4 times 2, right? Okay, so now we have 2 new numbers in the denominator. In other words, we have, you know, a 4b here and a 4b there. Why did I just think of old MacDonald had a farm? I don't know why. Okay, anyway. Okay, there's 4b is our common denominator. So one of the terms is 3 times b, and one of the terms is 4 times 2, which is 8. And really, that's all we need to do, right? That's it. There's nothing else we can do. We can't add these together. You can't say 11b or anything like that. You just stick them there. And that's all you need to do. If you do something to the denominator, you do the same thing to the numerator. If you do something to this denominator, do the same thing to the numerator. I mean, you're done. You treat these just like you would normal fractions, all right? Let's try another one. Copy this down. There are 3 fractions this time. Okay, well, you know, what do b and c and 2 all go into? Well, the answer is they all go into 2bc, right? Okay, well, let's just rewrite these 3 fractions again. Fraction plus this fraction plus this fraction. All right, on this one we have a b already, and this one we have a c, and on this one we have a 2. And we have a 4, and we have a 1, and we have a 1 already. I'm just writing what we already have. Let me go ahead and, okay, so we need it to be 2bc every single time. Well, to get from b to 2bc, you're going to have to multiply by 2 and by c, right? Well, if you do times 2c up here, you've got to multiply by 2c up there, right, as well, right, to make things even. On this one, we have a c. Well, we need to multiply by 2b, right? Well, we need to also multiply the time by 2b. All right, on this one, we have a 2. We want 2bc, which means we have to multiply by b and c. And you do exactly the same thing up there. It's just like normal fractions, you know? Okay, well, let's do this. 4 times 2c, that's going to be 8c. 1 times 2b is 2b. And then 1 times bc is bc. And since these are not, they're not like terms at all. There aren't any like terms. So I'm just going to put over 2bc. And that's all you're doing. That's all there is to it. This is exactly the same thing. When you used to do this, you went, oh, 5 over, 8 or something. And you're going to go, oh, they said, oh, change this to something with a 24. You went, okay, I multiplied by 8 times 3 is 24. So I go, times 3, that's going to be 15. I got it. That's exactly the same thing you're doing here. You figure out what the common denominator is. It's almost like the LCM. Same thing. Then you do the same thing that you did to the top that you did to the bottom each single time. Mash together any like terms if there are any, and you're done. All right? Copy this one down. Pause it. You tell me, what's the common denominator? XBC, right? There we go. XBC is the common denominator. All right, so let's just add our 3 fractions together. And then, yoink, there we go. All right, this one is, I'm just going to put 5 over x. This one is x over b. This one is a over c. All right, and let's figure out what we did to each one. We need this. We ain't got that. Okay, we got x. Well, we're going to have to go like this, times bc, which means to the top we go times bc. Do the same thing, all right? We have a b here, we need to go, okay, I need to multiply by x and b, or excuse me, x and c. So I'm going to have to multiply by x and c. This one, we need an x and a b. I'll just put x and a b over here because I don't have room enough. So I just go, okay, fine, times an x and a b. And there we go. So now all these have the same denominator. We can just put xbc at the bottom. And this is my, what? We got 5bc plus x times x is x squared c plus a times x times b, axb. And that's it. And they consider this a simplified fraction because they're just one fraction. Or simplified expression because this is just one fraction instead of three fractions. And there you go. All right, let's try another one. Copy, pause and copy and try this one. What's different about this one? Yep, that's it. Assuming you said there's no denominator on this one. Okay, and that's it. This is a piece of cake, by the way. What is the common denominator? Now don't say it's c to the 5th or c to the 6th or anything like that. Remember, on the old ones we did previously, we had to choose between or among the one with the highest exponent value. And so, in other words, visualize this bottom denominator of the first one as this. And the second one is this. And the third one is just 1, right? Well, what's the common denominator? Well, it's c to the 3rd power, right? It's going to be c to the 3rd power times 1, which is just c to the 3rd power. So this is what we're looking at right here. So that's going to be c to the 3rd power. That's, you know what, let me do it this way. Man, I almost erase all ink on all slides. Okay. This is what this looks like right now. C times c times c, and then there's an m there. The second one looks like this, c times c, and there's a 4 there. The third one looks like this, and there's just, I'll put a 1 there. Okay, of course there's 1s in all these. We don't need to do all that, all right? Well, what do we need to do to each one of those? That's the key, right? Well, to the first one, we need to do nothing because it's already c to the 3rd power. So that just stays the same. The second one needs to look like this. It doesn't. So we need to multiply it by c, which means we multiply the top by c as well. The last one, we're going to have to multiply by c times c times c, correct? Because we don't have anything here. So this one has to be multiplied by c times c times c, or just c to the 3rd power. Okay, and now we have a c to the 3rd power as our denominator. We have an m here plus a 4 times c, and then 6 times c times c times c is just c to the 3rd power. Do not, remember, don't try to cancel these out because it's an addition problem. It has to be multiplied. But that's it. That's all you need to do. And there you go. Okay? Pause it and try this one. You know, yeah, go ahead and pause it. Pause it and try this one on your own. Figure out what the common denominator is, and then figure out what you need to do to each fraction's denominator, and then do the same thing to the numerator, and unpause it when you figured it out. Go ahead. Well, first off, what is the common denominator? What do 4 and 2 both go into? Well, they go into 4, okay? And 4, 2, and b, they will all have to go into 4b. So let's go ahead and write our 3 fractions again. That's a minus this time. Ooh, they tricked us almost. Okay, so plus, all right, and this is a 4, and p over 4, and this is a over 2, and this is c over b. But it needs to be a 4b. So we're going to have to multiply this one times b, and then we're going to have to multiply that by b, the same thing, right? And so we're going to get to 4b here, which means we're going to have to multiply by 2b. In other words, you're starting at 2. To get to 4b, you have to multiply by 2b, which means we're going to have to multiply by 2b up here as well. And this one, we have a b. We're going to have to multiply by 4, right? To get to 4b, which means we multiply this by 4. Same thing, all right? So we'll go ahead and call the first term pb minus, we'll call that 2 up front. We'll just call that 2ab, and then plus, that's going to be 4c. And then the entire thing goes over 4b. And again, don't try to cancel these b's. You can't do it since this is a subtraction and addition between those terms. And that's it. I mean, this is all you're doing is finding out what the common denominator is. Looking at each fraction and going, what do I need to do to that bottom fraction to get to it? Okay, I do this, and oops, I have to do the same thing at the top, right? Okay. All right, we'll try one more. And we'll go to the practice problem. So This is not horrifically easy, but it's not too bad at all. If you can do this, you're in great shape. So pause it if you need to. Well, let's first look at the numbers. You can visualize this as a 1, that's a 4, and that's a 3. And of course, I think we all know that the common denominator is going to be 12, right? It's going to be a 12. Now we have a c squared, c to the third, and c to the fourth. Well, it's the same thing as the old LCM method. Remember that? You just choose the one that's the biggest, c to the fourth. That is our common denominator. So let's go ahead and rewrite our 3 fractions. Okay, so let's go. I'm just going to go ahead and copy all of them as they are. And then 3c to the fourth, and that's going to be m. Okay, so let's go ahead and figure out what we need to do to each one of these. We want this as our answer. Well, we have c squared. Well, this is a 1. So we're going to have to multiply by 12 first off, because we're at a 1 there. So what do we need to multiply c squared by to get to c to the fourth power? And the answer is c squared, right? So we're going to do exactly the same thing on top. 12c squared. Boom, we're done. All right. The second one, we have 4c to the third. We want 12. Well, from going from 4 to 12, we have to multiply by 3. And now going from c to the third to c to the fourth, we have to multiply by c to the first, right? c to the first times c to the third is c to the fourth. So we do exactly the same thing up top. Dunk. There we go. The last one, we need to get to 12c to the fourth. Well, we already have c to the fourth. We don't need to do anything because we're good right there. But we need to go from 3 to 12, which means we multiply by 4, which means we multiply this also by 4. All right, let's take each one of these in turn. 12 goes in the front there. A c to the second, that's the first term, plus 3 times 3 is 9c, plus m times 4, we'll just call it 4m. And all that is over 12c to the fourth. And that's the whole thing. There you go. That'll get you all the way through your entire life. Unless you want to, I don't know, make a living or, you know, marry somebody or, you know, buy a house or something like that. Okay, anyway, all right. If you're at a homeschool prom, you can just start talking about this stuff to the person, you know, with some guy you don't want to dance with. Just start talking to him about adding rational expressions with unequal denominators, and he'll back up slowly and stand against the wall and that kind of thing. So anyway, all right, well, let's try A, B, C, and D. And try A first and pause it and give it a whirl. Okay, well, we know the common denominator is 3m plus 2. That's a piece of cake. Don't these seem easier to do now that we did those last kinds? Okay. Now we have a 4m and plus a 6m. That's 10m. We have a -2 and a -4. That gives you -6, and that is it. Remember, don't try to cancel out the m's. You cannot do it with a plus and a minus in between terms. Okay, pause it and try B. Well, that was easy. 9 minus 7ap over xy cubed plus m. Okay, piece of cake. All right, here's where it gets interesting. All right, pause it and try C and come back when you're done. Okay, well, we have to do, you know, the common denominator. And we're going to have to include c to the third power. And we're going to have to say, we're going to choose the higher one of m cubed and m to the fourth, which is m to the fourth. That is your common denominator. That's what you want. I'm just going to go ahead and rewrite, you know, x and then m to the third. And then I'm going to write 1 over c to the third. And I'm going to write a over m to the fourth. Okay, let's go ahead and use a different color here so you can see these. So I want to move from here to there, which means I'm going to have to multiply by c to the third and m to the first to get to from m to the third to m to the fourth. So I do exactly the same thing on the top. This c to the third looks good on that. It looks great. I still need to multiply that by m to the fourth. And then, of course, that's what I do up here. This m to the fourth is fine, but I don't have a c to the third, which means I have to multiply this by c to the third and this by c to the third. So my total numerator becomes x and then c to the third m plus m to the fourth plus ac to the third, and the entire thing gets shoved over on top of c cubed and then m to the fourth, and there you go. All right. Pause it and try a d. That'll do us for today. Okay, well, we have to put 1 as our denominator here. So what do p squared and p to the third and 1 all go into? They all go into p to the third. And don't forget, don't get hung up with, oh no, 2 doesn't go evenly into 3. We don't care. Yes, it does. P squared goes evenly into p to the third. You can do the division yourself. There's p to the third, right? What's p to the third divided by p to the second? The answer is p to the first. Okay, so our common denominator is, that's gigantic, I don't need it that big. Our common denominator is p to the third power. So let's go ahead and do that. So there we go, plus, and then, ooh, they threw a minus in there. All right, so I got p squared, I got a p to the third, and I got a 1. Okay, so we got an m there, I got a 3, and I got a 4 there. Okay, so let's figure out what we need to actually change this to. So p squared, they all need to be p to the third. So I need to multiply this by p to the first, and I'll multiply that by p to the first. This is good the way it is. Stop right there. 1 times what gives you p to the third? Well, the answer is p to the third. So I do the entire top there. So I have mp plus 3 minus 4p to the third all over p to the third. Do not try to cancel this and this because that's an addition or subtraction. And there you go. Okay. There you go, guys. I hope that worked well. And hope you have a great day, and I'll see you next time. Take care now.